Hey there, my name's Erica Gilbert. I'm a flight instructor in Central Kentucky, and today we're doing a weather analysis from the perspective of general aviation pilots. Many of us are VFR only, some of us might have our instrument rating, and the vast majority of us are not flying aircraft certified for flight into known icing. So we're flying low and slow. We can't get over the weather, oftentimes we can't go around it, and many of us can't go through it. Today we're going to be looking at areas of VFR weather and areas of IFR weather and the hazards that exist within both of those. Welcome to AeroSafe. Today is February 16th, so it's Sunday, 10:06 in the morning Eastern and 15:05 Zulu time. We're going to be using the AeroSafe weather brief checklist to walk through this weather briefing today. This is available to you for free at gilbertaviation.com/aerosafe. It walks you through all the 91, 103 pre-flight action requirements and then dives a little bit more into the weather reports and forecasts that are mentioned in that regulation. Kind of step by step shows you the things you should be looking for and then presents some questions and considerations along the side as well. We'll be using 1-800-weatherbrief.com to go through this weather analysis today. And we're going to start, as we always do, with the surface analysis. We access the surface analysis by going to weather charts and then clicking on surface analysis. Okay, so for those of you who live on the East Coast today, you already know, probably by looking out your window, and you can see here that it is a nasty, nasty day. We have had here in Kentucky, we've had, I don't know, at this point, like 36 hours of precipitation. And then this morning, the temperature dropped low enough that it's all frozen. It's snow at this point, and we've had, looks like about half an inch of accumulation in the past couple of hours. And all of that is due to what we see going on up here in the Northeast. Lots of low pressure area, and then just a conglomeration of different fronts. Some more fronts, warm fronts coming up from the ocean, and then kind of a double header here, two cold fronts that have pushed down. And so on the leading edge of that first cold front, we see some convective activity, and this black line actually also indicates a little bit of a squall line. So squall line thunderstorms down in South Georgia, North Florida. And then on the back side of it, we get a lot of precipitation, frozen precipitation on the backside of those cold fronts. So lots of really nasty, yucky stuff there. The central part of the country looks pretty clear and nice, and I'm sure when we move over to looking at the METARs, that will be reflected as well. Probably VFR in this area, and I don't see much reason for there to be other hazards in the area, but we'll look at the AIRMETs and see. High pressure across the middle part of the country. A mix of pressures over Colorado, as we often see, and up into Wyoming, Idaho, Montana, a stationary front that kind of comes down through there as well. Some low pressure over Nevada and southern Idaho, and that is creating some precipitation there. And a cold front coming into the coast that's meeting up with a warm front, and then where they have already met, we get an occluded front. So remember, an occluded front is where a faster moving cold front meets a warm front, and we see that here. So essentially there are three masses of air that have now mixed together and are creating some of the worst weather that we could experience. Usually pretty bad weather. Okay, we'll refer back to our weather brief checklist. The next thing we want to look at are SIGMETs and AIRMETs. So for the SIGMETs and AIRMETs, we're going to move to the interactive map and pull it up. We'll start with SIGMETs. So along the leading edge of that cold front that we looked at, along the southeastern part of the U.S., kind of in the Georgia, Florida area, we did see some convective activity and a squall line, and that is confirmed by the SIGMETs here. We have a convective outlook saying that all of the ingredients for a thunderstorm are there. And so here's a check ride question. What are the required conditions for a thunderstorm to form? Well, if you have watched my weather knowledge for a check ride video, then you know that the three ingredients for a thunderstorm to form are sufficient moisture, unstable lapse rate, and lifting action. And we get all of those with the cold front here over the southeast. And then the white boxes indicate the actual convective SIGMETs. And when we click on those, we can see a little bit more information. Area of severe embedded thunderstorms moving from the southwest at 60 knots, stops to flight level 220, wind gusts to 60 knots possible. Now, one of these should indicate squall line. Here we go. Yeah, this one. Severe embedded thunderstorms from 270 at 60 knots tops to 300. Tornadoes, hail to 1.5 inches, gusts to 60 knots possible. That is absolute no-go. That is an impenetrable squall line of thunderstorms. What's really interesting is when you look at the flight category for the airports around this squall line, none of them are actually reporting IFR. Most of them are marginal or even VFR. And I say that to demonstrate that sometimes oftentimes VFR doesn't mean that it's safe, right? There are additional hazards in the area. So for example, we'll click this one here, Baxley. So 7 miles of visibility, scattered at 1,200 feet, broken at 6,000, overcast 10,000, and lightning in the distance. So you could easily look at that and go, oh, that's no big deal, right? I could fly IFR out of that. But if you just look at the flight category of the airport and you're not looking at all of the weather that exists around it, then you're missing out on a lot of really important information. So this whole area, as this squall line kind of pushes farther west, I would stay away from it. And then on the back end, we've got some not so great stuff as well. Strong winds. Here at Butler, Georgia. Winds from the east at 12, gusting 19. Okay, so we have SIGMETs for that convective activity along the leading edge of the cold front that we looked at in the far southeast. We have another SIGMET here for high-level turbulence. This is most likely going to be because it's reported by aircraft. Yes, and this is due to wind shear associated with the jet stream. It's been reported by aircraft. So chances are there's an AIRMET in this area, and then there were a lot of PIREPs reporting severe turbulence. And so they issued the SIGMET there. We've also got a convective SIGMET in far eastern Kentucky and North Carolina, West Virginia area. Area of severe thunderstorms moving from the west at 55 knots. Wind gusts to 60 knots possible. And then we have a SIGMET also over the Great Lakes. Occasional severe rime icing between 1,000 and 7,000 reported by aircraft. So SIGMET for icing up there means that it's really bad right there. One of the things that's important to remember is that these AIRMETs and SIGMETs are somewhat drawn by people with straight lines, and natural phenomenon don't happen with straight lines, right? There are no 90-degree angles in nature. And so knowing that there's a SIGMET here, if you are right on the outside, say here at Kellogg, just because you're just outside of that AIRMET, that doesn't mean there's not going to be icing. So let's now look. We've seen those SIGMETs. We've got severe high-level turbulence. We've got a couple areas of convective activity, and then we also have severe icing. Let's turn off the SIGMETs and look now at the AIRMETs. I kind of want to look at the Zulu first. So that SIGMET for icing was up here by Lake Michigan area. So that icing SIGMET was up here over Lake Michigan, and we also have icing AIRMETs around there from the surface to 7,000 here, and then 8,000 to 18,000 here. And then alongside the back, or I guess right over that cold front, there's an icing AIRMET as well, from the freezing level, which ranges between 8,000 and 12,000, all the way up to the tops of 25,000. So that's something that we're not going to be able to get over, and we're probably not going to want to fly under it either. Again, that whole area I would steer clear of today. We have more icing AIRMETs up in the northwest. Bases 5,000, tops 18,000, and then bases 10,000, tops 19,000. Now, this icing AIRMET with the bases at 5,000 seems nice and dandy if you're from relatively flat land like I am. But we'll pull up these AIRMET Sierras, and you bet your booty there's going to be IFR and mountain obscuration in the area as well. So the question with those AIRMET Zulus, those freezing AIRMETs, is where are the bases, and can I maintain, if I'm IFR, can I maintain a safe altitude while being below the freezing level? So some people, they work into their personal minimums when they're flying IFR, that they want to have the temperature at their cruise altitude be, X number of degrees. What I would say is I do want you, when you're setting your personal minimums in relationship to icing, look at your route without looking at the weather first and determine what altitude you would be comfortable flying at first. And then look and see if the freezing level is near there or not, because you don't want to skirt your level of comfort in one way to mitigate one risk, right? So if you look at a route and you say, okay, 9,000 is the lowest I'm willing to go here, and then you look at the freezing level and the freezing level is right at 10,000, that's a little too close. That would ultimately result in a no-go situation. And that, of course, is important when we're talking about mountainous terrain. And we can take that a step further. For me, there are 3 really big situations that can result in additional risks. That's mountainous terrain, instrument conditions, or nighttime. And I'm only willing, in a piston aircraft, I'm only willing to accept 1 of those at a time. Definitely not 2, and absolutely not 3. So we've got IFR and mountain obscuration in the northeast and the northwest, as we often see, and that is verified by the flight categories in those areas as well. Pullman has a special observation, winds from the east at 10 knots. We have 1.75 miles of visibility. There is snow and mist, few clouds at 900, broken at 15, overcast at 2,000. All right, here is a check ride question. We're looking at Dillon, Montana here. Winds are from the southeast at 6 knots, scattered at 6,000, scattered at 8,000, overcast at 11,000. Temperatures -7, dew points -10. Yucky. Okay, check ride question. What is the lowest ceiling at this airport? The answer is the overcast layer. So a ceiling is the lowest layer of either broken or overcast clouds, meaning that these 2 scattered layers are not ceilings. All right, so we've looked at the areas of IFR and mountain obscuration, and for the most part, those overlap with the AIRMET Zulus. So now let's look at the Tangos now. Here's a check ride question. What do AIRMET Tangos get issued for? AIRMET Tangos can be issued for 3 things. Either turbulence, could be low, could be high, low-level wind shear, and sustained surface winds of 30 knots or greater. And I believe we have all of those on the map today. So here over Colorado, we have low-level turbulence and low-level wind shear. So airspeed loss or gain of 20 knots or more. Low-level wind shear also in California going up into Oregon. The green AIRMETs are high-level turbulence. And then over in the East Coast, we've got everything going on as well. Low-level wind shear, low-level turbulence, sustained surface winds greater than 30 knots. So that's off the coast there. So I'm sure none of you guys are flying over there, but all of those indicate that this is really yucky weather. Low-level turbulence, surface to 16, surface to 18,000 feet. I am not flying today, that's for sure. Mostly because of icing conditions, low ceilings, all of that. So if we turn on all of these AIRMETs and SIGMETs, what I like to say is that the prettier the map looks, the less likely I am to be flying. And so we see lots of holes in the cheese, lots of factors that contribute to a no-go situation along the East Coast and along the Northwest. This area over Arkansas and Missouri is interesting. Let's look at it. Mountain Home. I've flown into there to go fishing on the White River. Okay. Winds 350, 9 gusting 20, and the wind is variable from 310 to 020. Overcast at 1900. So this area is super windy. It's a widespread area of marginal VFR, meaning the ceiling is between 1,000 and 3,000 feet, and the visibility is between 3 and 5 miles. So a widespread area of marginal VFR, for me at first thought, I'm thinking, oh, this might be a good area to go do some practice approaches. However, when we look at the winds, it's like here in Cleveland, 9 miles of visibility, winds 320 at 17, overcast at 24. Ceilings variable between 2,100 and 2,800. For me, I would look at that, and my first thought is, okay, maybe we could do some practice instrument approaches, relatively high ceilings, but low enough that we can get some instrument time and log the approaches and, have a lot of benefit there, as long as you're instrument current and proficient. But when you look at the winds, that kind of adds in that additional factor, that additional hazard of, well, is that within my personal minimums? What is the crosswind component? What's the maximum demonstrated crosswind component for the airplane? And what do I feel comfortable flying in? And probably I would just not do it that day. I'd want to see a little bit more calm of a day. And that whole marginal VFR area is kind of yucky. Something like Ruston, I'd probably be more likely to do that with the wind only gusting to 16 knots, depending on the orientation of the runway. And then, it's interesting that there's no icing AIRMET, because here at Longview, the surface temperature is 2 degrees and the dew point's -2. So there's not a huge spread there, and the dew point is below freezing, which means that any visible moisture would result in the accumulation of icing. Now behind that though, in the very central strip of the country, like North Platte, Oklahoma, it was a really beautiful day. Super cold though, holy moly, -16, -20 dew point, scattered at 7,500. Lubbock, Texas, really nice as well, and expected to kind of stay that way. So looks like central part of the country is going to be one of the few areas that I would want to be flying today. Maybe also in Arizona. Yeah, around the Arizona area, which, you know, Phoenix, there's a whole bunch of flight schools there, and there's a reason, because the weather stays pretty nice most of the time. The one consideration that you would need to make if you were in this kind of central strip is it does look like it's really cold through most of that part of the country. So you'd want to be sure that you preheat your engine if appropriate. If you're not hangared, you don't want to do damage to your engine on start or on run up as well. Okay, we've looked at SIGMETs and AIRMETs. Let's look at PIREPs. I'm sure we will see some PIREPs that support what we saw earlier, and we do. Basically, all of these PIREPs support the AIRMETs and SIGMETs we've already looked at. Here's an urgent one down here. I like looking at the urgents. Low level wind shear and a DA 40 at 300 feet. 737, low level wind shear between 500 and 1,000 feet during descent to runway 35. 737. Okay, that would be a little more exciting than I would want. Okay, so here up near where we had some SIGMETs, we got a PIREP for severe turbulence between 27,000 and 28,000. And there are other PIREPs for less severe. Here's another urgent. So in all those areas we already looked at, there are PIREPs for turbulence, there are PIREPs for icing, there are PIREPs for low-level wind shear, and so those support basically the decision we already made, which is where the map is most colorful, we're not going to fly today. Now, normally, one of the things I would look at next would be the cloud coverage chart, but we already kind of determined there's not many areas where I would want to be flying where there's clouds, so we'll skip that one today. Freezing level, we'll look at that one real quick. So throughout most of the country, vast portion of the country, freezing levels on the surface. It's not until we get farther down near Florida that the freezing level really comes up, and as that cold front moves into Florida, it's going to come down anyway. All right, winds aloft. If you were doing an actual flight, you'd want to make sure that the winds aloft at your altitude had been briefed so that you knew how that would affect your ground speed and therefore your fuel burn to make sure you have enough fuel. Aviation surface forecast. We will look at that. That's going to be on weather charts. We'll look at decision support graphics, graphical forecast for aviation, 3 hours from now, whole US and surface. Yeah, and this shows everything that we already talked about. So lots of precipitation, lots of frozen precipitation, low visibilities, and thunderstorms. Area of IFR and mountain obscuration, and precipitation here. And then also very windy in that central corridor of the United States. So there's a lot of hazards going on today all across the country. We already kind of looked at METARs and TAFs, and then if you were doing an actual cross country, you'd really want to call 1-800 Weather Brief and talk to a briefer. Take the opportunity to talk to a real person, someone who's trained in this area. They'll be able to give you a lot of information about what the weather's doing, what the trends are, and help you make a decision. You know, you can ask them questions, say, hey, what do you think about this route or that route? And you want to make sure that there's nothing that you missed in your weather briefing and your self-briefing. Last thing we're going to do is look at the surface Prog charts here. These are going to give us an indication of where those pressure and frontal systems are going to move over the next couple days and how that's going to affect the weather that we see. So this Prog chart is for 12 hours from now. That cold front will have moved further south and east, and we see that is causing some convective activity further south into Florida, but the far northeast is going to have a lot of the same stuff. So icing and frozen precipitation and that low pressure system hanging out is going to make it really nasty up in the far northeast. Northwest, still an onslaught of frozen precipitation. It's just that time of year, but it does look like maybe Central Corridor is going to look nice. 24 hours from now, so 10:30 Eastern on Monday the 16th, it looks like the systems haven't really changed very much, if at all. Is that the same? Oh, they barely move. Okay, so I guess things are really not changing over the next day. Everything's just hanging out. A day and a half from now, that's where we really see some change. Looks like things might be just starting to clear up on the East Coast, but then some precipitation's kind of moving down through the central part of the country. Northwest, so sorry. I think it's time to move. 2 days from now, same story. Looks clearer in the southeast. Southern part of the whole country, it looks like it might be pretty nice. We'd have to see what was going on with these different fronts and troughs. And then central part of the country, it looks like you guys are going to be getting some snow. So, big point for today is that there are hazards all across the country. And if you're looking at flying today or tomorrow and the next little bit of time, you really want to be sure that you're getting a thorough weather briefing, because there are some areas where the go or no-go decision is not cut and dry. And there are areas where it's very obvious that you're not going to be flying, like today here in Kentucky. I mean, I can't even see over to the next ridge because there's blowing snow. So we're not flying in this part of the country today. There are some parts of the country where you could fly VFR and you could fly IFR, but it's very windy. So you need to be mindful of, hey, is this within my personal minimums? Have I landed in this before? Am I current? Am I proficient? You'd want to have all of those thoughts rolling around in your head after you did a very thorough weather briefing to determine if the hazards for you were within the acceptable level or not. Northwest, same thing. Very beautiful map with the graphical AIRMETs on there. So I would stay on the ground today. Now, as an instructor this time of year, I have several students that have scheduled their check rides and have had to be pushed back a couple times due to weather. And that's hard for anyone to face, when you've spent so much time and effort preparing for a check ride and you're ready and you get all your endorsements and everything's good to go, only for it to be pushed back. That can be really difficult, not just from like a mental standpoint, but also a preparation and a financial standpoint. So I'm curious, have you had any setbacks so far this winter in your flying? Maybe it's not check ride readiness, but maybe it's solo readiness, or maybe you've had to push back a written exam. I'm curious, what are you struggling with right now in your flight training, and what are your plans to overcome it? Thanks so much for tuning in. We'll see you next time.